Hello, my name is Duff, and today we'll be going over cRule. Now, if you're diligent, you would notice that Procyon already covered the cRule. However, I got permission from him to remake it since the video quality isn't
This is the
great.
story of
All available experts, please report to room A9.
Alright, this is the cRule. It is imperative that you know how to operate the rule before you try the cRule. So, what we do here is, I need to get my setup for this one. I should have got prepared. If you know how to do the rule, this is essentially the same, except this time, there is no rule number at the top. There is a reset button, which I'm pretty sure is new. And as you can see, there's a bunch of symbols and colors. Now, to get your rule number, so each one, there's 3 colors, well, 3 color channels. The 3 color channels are red, green, and blue. Now, I suggest watching the Simon Says tutorial to know your color addition, but I'll just go over it real quick. Red plus blue makes magenta, red plus green makes yellow, blue plus green makes cyan. And all of them make white, none of them make black. So, with that in mind, we need to get the rule number for each color channel. And the way we do that is by doing the following. So, each one of these symbols in the manual correspond to a number. And we add that number to the sum of the digits in the serial number. So in this case, we're going to add that to 12. So just so I don't forget, like a moron, we're going to put plus 12 at the top. And if the symbols are in a primary colored square, then the rule number is going to apply to that color channel. If it's in a secondary color
Emergency
channel,
cleared. All personnel, please return to your stations.
Rather a secondary color, then the rule number applies to the color channel that is not present to make that secondary color. But first, let's start by Pendulum Squares. So, let's take a look at the red one real quick. Red is in magenta, so we colored this one. Red is not in cyan, so we get rid of that one. Red is in red. Nothing makes a black. Red is in yellow. Red is here. Forgot to make that not there. We have an X here. Red is not here, nor is it here. For green, it's not here. It is in cyan, so we put green here. It's not here, nor is it here. Green is in yellow and green is down here, and these bottom 2 squares are also green. I need to put this as green, as a no as well. There we go. And now the blue is in magenta, blue is also in cyan, blue is not in red, black, yellow, or green. But it is in cyan. And this F1 is going to be the final result, so once we re-add all of them. So, once we have that in mind, let's take a look at the rule numbers. So, as we can see, there's 2 spades within this red box, and since it's a primary color, the rule number is going to be applied to the red channel. So, we had 2 spades. 2 spades. And 2 spades is going to be 0. So 0 plus 12 is going to be 12, and if we turn that into its binary representation, it's going to be 1, 1, 0, 0. And turning that back into the rule numbers that it applies to, it's 1, 1, and 1, 0. So, because we don't start at the top like normal, we're going to have to do a little bit of reverse engineering. So, let's take this, let's see. Let's take this this square, for example. We know that we know that 1 and 0 is a positive value, so we're going to put an R there. And 1 and 0 here is going to put a 1 here. However, since this is an X, that means it has to either be 0, 1 or 0, 0. Now, the nice thing about cRule is that it has multiple correct solutions. So if we extend all the way back up here, if we make this one an X, this one can be an X as well. The top row can be any color that you want, basically. So if this is an R, then I can, this can be an R, a 0 or a 1. It doesn't affect this outcome though, so I'll keep this as an X. If you make a move that is illogical, then it will strike you. Let's take a look at this square, for example. If, since we have an undetermined 1 or 0, we have to look at the other two. The offspring is a 0, and B is also a 0. This can't be a 1, because if it were a 1, then this would have to be a 1, meaning that this has to be a 0. And same thing applies here. Since this is a 1 and this is a 0, this would have to be a 1. Oh, that's right, R, not 1. Allergies. Let's see. Let's take a look at this square, for example. All we need to look at is this square right here, since basically only the A parent determines the whether this is a 1 or not. Since this is a 0, neither of our correct solutions start with a 0, so this also has to be a 0. Let's see. This cannot be a 1 because this is a 1. And if both of these were 1, this would have to be 1. So therefore, this has to be a 0. And same rule applies here, and also here. Since we have a 0 here, and a 0 here, this would have to be a 0. 1, 0 makes a 1. 1, 0 makes a 1. Let's see. Let's make this nice. Actually, no. Let's start up here. We have two 1s, so if this were to be 0, 1, then this would be invalid, so this has to be a 1. 1 and 1 make 1, and 1 and 1 make 1. Let's move on to G. So this one is in a primary color as well, which is Heart Diamond. Heart Diamond is a real number of 14, and 14 plus 12 is 26. We're going to modulo that by 16 to give us 10. And 10 in binary is 10, 10. Meaning that it's 1, 1 and 0, 1. If you want to look at this at a faster route, that the basically you're going to look if B is 1. And if B is 1, then that means that you're going to color the respective square. So let's take a look here. Let's take a look at this one. We don't know either one of these pairs, but we do know that this is a 1. And since B is always B would always have to be valid for this to be valid, this would have to be a 1. 1 and 1 make 1. Since this is a 1 and this is a 1, this would also have to be a 1, and same thing applies up here. This is 1, so this can be either one of these. Actually, no, it can't. If we take a look at this case, in just this case, then this could be any either a 1 or a 0. However, we also have to look at this case. If this were to be a 0, then this would be invalid, so this has to be a 1. This can be anything we want. Actually, I'll come back to that one later. We have a 1 here, so that means that this has to be a 1. This is a... let's see. At this point, there is no other moves that we're forced to make. And since there's no other moves that we're forced to make, like no 1s and no 0s, I'm just going to put everything as an X. Well, everything as a 0. And as you can see, if B is active, then the offspring is going to be a 1. Now let's take a look at B. Now the only symbol left that we have is in a secondary color. So red and green make yellow. So since blue is not present when making yellow, this is going to apply to the blue channel. So we have diamond and spade. Diamond and spade is going to be the rule number 8. And 8 plus 12 is 20. Modulo 16, that is 0100. And turning that back into its rule number counterpart, that's just 10. So, let's see. We have a B here, and since this is a 1, and there's only one possible outcome we can have, well, one input we can have that leads to this outcome, this has to be a 1, and this has to be a 0. This input is different, is not the same as this input right here, so this has to be a 0. Same thing applies here, and since this is a 0, but this is a 1, this would have to be a 1. And same, let's see, what other move am I forced to make? Okay, let's think ahead for this one. So let's say, for instance, that this were to be a 0. If this is a 1 and this is a 0, this would have to be a 1. And if this were a 1 and this were a 0, this would have to be 1. However, that is not the case. This is a 0. So that means that this, not only does this have to be a 0, but this also has to be a 1. Right here we can have either a 1 or a 0. I'm gonna make it uniform and just have it be a 1. This produces nothing, and 2 zeros also produce nothing. Let's see. So we have this 1 right here, and we have a 0 on the right. So that means that this has to be a 1. And for this to be a 1, this would have to be a 1. Oops. And this would have to be a 0. This can be a 1 if I want it to, but I'm just gonna make... Actually, yeah, I'll make it a 1. 0 and 1 make nothing, and 0 and 0 make nothing. So, let's put this back into the final chart. However, I'm going to put down the squares that were already present. So, I'm going to put down magenta, cyan, red, black, yellow, green, red, green, green, and cyan. And that's just so I don't accidentally color something I shouldn't. So, let's see. If we take a look at this square, red and blue are active, and red plus blue makes magenta. If we look at this third square, red is inactive, green is inactive, but blue is active, so this is going to have to be a blue. For this square, red is inactive, green is inactive, and blue is active, so that has to be a blue. For this square, red is active, green is inactive, and blue is inactive, so this has to be a red. For this one, red is inactive, green is active, and blue is active, so this has to be cyan. Red is inactive, green is active, and blue is inactive, so this would have to be cyan. For this one, red is active, green is inactive, and blue is inactive, so this has to be red. Red is inactive, green is inactive, and blue is active, so this has to be blue. Red is inactive, green is active, and blue is inactive, so this has to be green. Red is active, green is inactive, and blue is inactive, so this has to be red. Let's see. Red is inactive, green is inactive, and blue is inactive, so this has to be black. Red is inactive, green is active, and blue is active, so this has to be cyan. Red is active, green is active, but blue is not active, so this has to be yellow. Red is active, green is inactive, and blue is inactive, so this has to be red. Active, inactive, inactive, so this is red. Active, active, inactive, so this is yellow. And then we plot the colors back down. So, we just click any one of these colors, and we're going to basically just plot down each color. So this is red, then 3 cyans, then red, red, black, blue, yellow, green, green. Oop, that's not green. Red, red, black, so red, red, black, cyan, yellow, green, and then red, red. If you forget which square is starting, you can press the reset button and it'll bring you back to the initial state.
No, perhaps not.
Let's see what I did wrong here. Okay, my issue was that I apparently input just a wrong color at the end. I meant to color this yellow and I colored it blue. But I did everything else correctly. I just fat-fingered, well not even fat-fingered, I just became a moron and thought red and blue and yellow were the same color. So this will become blue, yellow, green, green, red, red, black, cyan, yellow, red, red, and this is yellow. And this should be correct.
This was exactly the way, right now, that things were meant to happen.
Let's do a second example, but first let me just Control-Z all the way.
All available experts, please report to room A9.
Bruh. So, this one's nice. We have a white square first of all, and we have all of them being secondary colors. The sum of the serial number digits is 13, 19, 19. We modulate that by 16, which gives us 3, so we're going to add 3 to each one of our real numbers. Now let's plot down each one of these. First, I forgot to write down, well not write down, but rather just put down F for the final one. So we have yellow, then magenta, then white, then cyan, then red, then yellow, then magenta, and cyan. Okay, splitting these up into the color channels. This is red, this is red, this is red, this is also red, and this is red. This is not red. This is red, this is red, this is red, and this is not red. For green, this is green, this is green, this is not green, so we skip that. Well, not skip it, but mark it down as incompatible. This is green, this is green, this is not green, and green, not green, and green. This is not blue, nor is this one. This one is though. This is blue, and this is, not blue. Not blue, not blue, not blue. No, that is blue, my bad. Blue, and then blue. So,
Emergency cleared. All personnel, please return to your stations.
let's take a look at this one. Cyan is composed of green and blue, so this is the red rule number. I forgot to write down the +3. So, we have diamond and spade. Oops. I should probably close that out. So diamond and spade, what was it? Is 8. 8 plus 3 is 11, and the real number for 11, well, the binary representation of 11 is 1011. So, that is 11, 01, and 00. So let's do some deductional reasoning here. So, we know that 1 and 1 gives us a 1, and this could be either a 1 or a 0. I'm going to make it 1 because it makes my life easier. Same thing applies here, same thing applies here, and here. And I'll leave that one blank for now because we haven't discovered this. This is a 0, and the only time when it's a 0 is when the parents are 1 and 0. So this has to be a 0. Because this starts with the 0, this has to be, like the left one is 0, this has to be a 1. Let's see. This has to be a 0 because if it were 1 and 1, that would be a 1. However, it's not 1, it's a 0, so this has to be a 0. This has to be a 1 because this is a 0. And since all these are filled out, I'm going to make these both 1s. And over here, we can also make these 1s. Let's take a look at green. This one is made of red and blue, and that is spade club. Oops. Spade club is a rule number 1, and 1 plus 3 equals 4. So that is 0, 1, 0, 0, which is just 1, 0. Again, since there's only one possible input to receive the output of 1, we know this has to be a 1 and this has to be a 0. This is going to be a 0 because that's 0, 1. Same thing here, and same thing here. Same rule applies here. 1 and 1 gives us a 0, so that turns off. This is a 1, so that means the parents have to be 1 and 0. Same thing applies here. And let's see. This has to be 0 because that starts off with a 0. And this can be 0, this can be 0. This is going to have to be 1. This has to be a 0, meaning this has to be 0, and the reason why this is a 0 is because this is a 1. And I'll make it a 1 because why not? Now we have blue here. Blue is not present in yellow, so it's club spade. Yes. Club and spade gives us a rule number 4, and 4 plus 3 is 7, which is 0, 1, 1, 1, which can be rewritten as 1, 0, 0, 1, and 0, 0. So a NAND gate, if you will. So, because this is at least 1, 0, this is going to be a 1. Same thing here. Same thing applies here and here. Let's see. This has to be a 0. This, let's see. Since this is a... hold on. This cannot be a 1 because 1 and 1 would make a 0. Actually no, this has to be a 1 for that exact reason. So, let's see, is there anything else that I'm missing here? This square cannot be determined, nor can this one. This one has to be a 1. I mean, yes, a 1. Meaning that this one is a 0, and this one is a 1. Let's see. I'm going to make this a 0, and make this a 1. Let's see. This would have to be... well, actually it doesn't have to be anything. Let's see. This one has to be a 1, so 1 and 1 would make a 0. And same thing applies here. This would have to be a 0. And to make my life easier, I'm going to make all of these up here 0s. And now we have all 3 grids. So let's line them all up. Red plus green. Okay, so it's red and green, and that'll give us a yellow. For this one, we have red and green to give us a yellow again. Just red, so that'll put down a red. We have just blue, so this is going to be a blue. And this is just red. For this square, we have red and blue, so that's going to be magenta. This one is the same, it's red and blue again. This one is blue and red, so that's also magenta. And this one is also magenta. This one is just red. This one is black. This one is white. And this one is magenta. This one is magenta. This one is magenta. And this one is yellow. So let's put all of these down. 3 yellows, then red, then yellow, then blue, then magenta, then red, then 2 magentas, a white and a magenta, then another magenta, 2 reds, then yellow, then black, then white, then magenta, then magenta, 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 yellow.
But there is no answer.
So
How
I
could
did
there
wrong here.
possibly be?
Okay, like before, I just colored in something like a moron that I shouldn't have colored in. So, if I put everything back, this is yellow. My mistake was putting down magenta instead of red for here. So, white, then white goes here, and magenta goes here, magenta goes here, and red goes here. Blue goes up here, magenta goes here, here, and here. There are 3 yellows, then a red. This is rails. Yellow, red, yellow, blue, magenta, red. Magenta, magenta, white, magenta, cyan, red, magenta. Red, yellow, black, white, magenta. Magenta, cyan, magenta, yellow. This looks right.
This was exactly the way, right now, that things were meant to happen.
And that is the cRule. I hope you learned it. If you have any questions, leave them in the comments below, and get a job.